Redox reaction,
Reduction
sir.
reactions, some problems we have discussed, and certain points we have discussing, right? Okay, let's start. Types of redox reactions we will go. Now you understood now what is meant by redox reaction, etc. Yes or no? You have understood kada nana? What is redox reactions?
Yes, sir.
Understood or not? Hello.
Yes, sir.
Yes,
Mm, okay. Now we are going to discuss certain points like so basically what is redox reaction, we can say the reaction in which oxidation and reduction both are going to takes place, है ना? That means only no, the reaction in which both oxidation and reduction both are going to takes place. Now the question is types of redox reactions we are going to discuss. Okay, types of redox reactions we are going to discuss. Okay, the types of redox reactions we are going to see right now. Generally, let's start our session today. Mm. And before that one, certain compounds are there. How we are going to discuss? Mm. Share option. You can see now, students.
Yes, sir.
Next one, types of redox reactions topic. Types of redox reactions. First one is uh, combination redox reactions.
sir. Yesterday I was absent. What did we discuss yesterday, sir?
Who is speaking?
Ethics, sir.
You are not there yesterday.
No, sir.
Redox reaction rules we have continued. We have solved certain examples.
Okay.
What is combination reactions? Tell me what is combination reactions, Nana? Combination reactions means what, Nana? Hello. Combination reactions is what we can say simply when two are combined. No, you are not responding. Combination reactions, you have studied no types of reactions: combination, displacement, decomposition. Let's see. So combination reactions means two atoms are going to combine to form new reactions. Like for example, magnesium, when it reacts with oxygen, what we are going to get? We are going to get magnesium
Magnesium
oxide.
oxide, sir.
That means what we can say, two reactants together we are getting one product, isn't it? Now,
Yes, sir.
in this one we need to check whether it is a redox reaction or not. So to get redox reaction, what is the condition? It's supposed to be what it's supposed to be. It should be oxidation as well as reduction should also take place. No, for example, general magnesium oxidation state is 0, and normal O2 oxygen also 0 it will be there. And in this one, what we can say, so here magnesium will be +2 and oxygen will be -2. Now where you can find change? Magnesium 0 to +2 and oxygen 0 to -2. In case of magnesium, it is loss or gain. 0 to +2 means
Loss, sir. Loss of electrons.
so loss of electrons. And 0 to -2 means gain or loss.
Gain, sir.
So when there is a loss of electron, gain of electrons are there. That means what we can say,
Oxidation
it is a
redox.
redox reaction, no?
So both are happening please. So
Mm.
both are taking.
So that means what we can say, it is redox reaction, right? And it is a combination. That's why it is called as combination redox reaction. Okay. Next, in the same way, magnesium plus by reaction with nitrogen, it will form magnesium nitride. Okay.
So 3M.
Now tell me whether this reaction is first combination reaction or not.
Yes, sir.
Hmm. Now check whether it is redox reaction or not.
Yes, sir. It is redox only, sir.
How?
Sir, because in this Mg 0, sir. It's charge.
And N2 also?
N2 also 0, sir. But
Very
here
good.
Mg gets +2, sir. N gets -3, sir.
Very good. So 0 to +2 means again loss. N3 to -3 means gain. So this is loss of electrons. So loss of how many electrons it is? 2 electrons and gain of 3 electrons. So it is a
Sir,
reduction.
always magnesium will give electrons, sir.
Magnesium is metal, no? First A group element, second A group elements, no?
Yes, sir.
Okay, na? Likewise, we can write reactions like carbon plus oxygen by reaction with we will get CO2. Other examples, okay, na? Aluminium by reaction with oxygen, it will give aluminum oxide. Next, iron by reaction with oxygen, Fe2O3. These are all we can write as a combination and okay, for balancing, let me take 4 F here and 2 Fe2 over here. So 3O2 done. Okay, now these are all combination redox reactions. And let me take one more example. Tell me whether it is a redox reaction or not.
Yes, sir.
And it is, see, what is the oxidation state here? Tell me, Nana. Carbon -2, no?
Yes, sir.
And here it is +4, and here it is
It's zero.
+1.
Sir, but it should be zero, right? Because H2.
H2 in combined form, no?
Yes, sir.
That's why it is not 0.
Okay, sir.
Okay. -2 to +4. Gain or loss?
So last
Properly
Sir,
think. Gain or
sir,
loss? Tell me, Nana.
sir, loss.
Loss of electrons. How many electrons can you tell me?
Sir, 6, sir.
Very good. And 0 to -1, -2, it is gain.
Again, sir, 2 electrons.
Gain of 2 electrons per molecule. 3 molecules means 6 electrons as test. And it is what we can say, it is not a combination redox. It is a combustion redox reaction. Because this reaction is combustion is called, no? This reaction is called. Combustion it is combustion redox reaction. Combustion means you know, no? What is, we can say?
Yes, sir.
Yes or no?
Yes, sir.
Next,
Sir,
tell me, Nana.
that means it is exothermic, sir.
Combustion reactions are always exothermic reactions, no?
Sir, that means it has H2 on it, sir. Then how can it become combustion?
Combustion means what? The product we can't define, no? Combustion means it is reaction with oxygen. Okay. So here H2 also what? It will not come in terms of liquid form. It will come in the form of a gas. Okay, na?
Okay, sir.
Next. Done. Next one. Decomposition redox reactions. Next type is decomposition means what? What is meant by decomposition, Anna? Mm. What is decomposition redox reaction? Decomposition means one compound is becoming into decomposed, so becoming into two or three, and it is a redox reaction if it's taking place. Then we can say it is a decomposition redox reaction. We can say, okay, na? That means one compound will split into two compounds. That we can say decomposition redox reaction. Next one example, let me take. The compound name is potassium chlorate. Potassium chlorate. When it is decomposed, it will form KCl plus 3O2. Ah, find out oxidation states and tell me where to where you observe change.
Sir,
Oxidation state, tell me.
sir, that means can I tell the oxidation state of KCl or O3, sir?
All unique required. So
Okay, sir.
every atom you need to calculate oxidation state. In the total entire reaction you need to calculate. Okay, now we can say clearly it is a decomposition reaction because the one compound is splitting into two or more than two. We can say it is decomposition. Now I am asking it is a redox reaction or not. So that can be identified by writing oxidation states only. Tell me, students, this much of time.
Sir,
Hmm. Tell me.
sir, can repeat your what you're saying again?
See, here oxidation state of potassium what? Plus 1 and chlorine minus oxygen minus 2. So chlorine will have plus 5. And here I have plus 1. Chlorine will have minus 1. And here it is 0.
My zero.
Now where you find change? Plus
Sir,
5 to minus 1,
chlorine
minus 2 to 0. Plus 5 to minus 1 means gain or loss?
the loss, sir.
Huh? Plus 5 to minus 1, na?
So gain.
It is gain, no? And it is loss. So a loss of electrons and gain of electrons is taking place, and it is a redox reaction and decomposition too. Okay. Let me take this reaction.
Sir,
Tell me, Nana.
can you tell what is decomposition?
Decomposition means when one chemical is converting into two or more than products by reacting or by heating, it will convert into two or more, decompose it will.
Okay, sir.
Tell me in this one oxidation state. Tell me fatafat.
Uh,
Carbon, calcium plus 2, here minus 2, so carbon is plus 4.
Sir, calcium again +2, oxygen -2. Sir, +4 also.
Plus 4 minus 2. Tell me it is a decomposition redox reaction.
It should be 0, right, sir? Because O2 means it will be 0.
O2 where we are not getting? We are not getting O2, no?
Sir, we are getting carbon
Okay, sir.
dioxide.
Whenever you find O2 alone, that is in the form of oxygen,
We will get 0, sir.
then it will be 0. But if it is in the combined form, no, it cannot be 0. It is a decomposition reaction, but it is not a redox reaction.
Sir, all are same, sir. Oxidation state are same.
But means we are not finding any change, no? Not a change in different reactions or not. So it is not a redox reaction, but it is decomposition reaction. Understood what is decomposition, decomposition redox? Am I clear, students? Next one, okay, displacement reactions. What is mean by displacement reactions? Displace means one will replace. Okay, one will replace. For example, in this displacement also we are having first one metal displacement reactions. Metal displacement reactions. That means one metal will be displaced by other metal. Generally, low active metal can be displaced by high active metals. Okay, na? Now see, for example, when you react with zinc, when you react with copper sulfate, no, it will form zinc sulfate plus copper. Okay. Now in this one, try to find out oxidation states. ఆక్సిజన్ స్టేట్ క్యాలిక్యులేట్ చేయడమా?
So Zn is +2.
Here what we can say, zinc generally metal 0, and here oxygen -2, sulfur +6, copper will be +2, and here again oxygen will be -2, sulfur will be +6, zinc will be +2, and copper metal again 0. Now here see, if you observe, zinc when we react with copper sulfate, that means what we can say, copper is replaced by zinc, no?
The zinc is more reactive than copper.
That means what we can say, so zinc is replaced by copper, no? So that's why what we can say, copper is replaced by zinc. Now here find out oxidation state change.
So loss.
Loss of electrons, loss of 2 electrons, and copper.
The gain 2 electrons.
So okay. That means what we can say, it is a displacement reaction as well as it is a redox reaction. So it is called as displacement redox reaction. Okay. In the same way, for example, aluminum, when you react with Fe3O4, this we will get Al2O3 plus Fe. First balance nana 4, 3, 9,
8.
8. Balance this. Sorry, we have balanced. Tell me. It is a metal displacement reaction, right?
Yes, sir.
Yes, sir.
Because one metal is displaced by other metal, so metal displacement reaction. And now let's go with oxidation state. 0, -2, +3, -2. Iron, it will be how much it is, Nana? Fe3O4, no? Plus 8/3. And here 0. 0 to +3 means what we can say? Loss.
The loss of 3 electrons.
And iron to this means?
Gain, sir.
The gain of 8/3 electrons.
So it is redox reactions. Okay. So here total number of electrons, how we will gain, how we will calculate, see. Generally one iron is of 8/3, right? Isn't it or not? Total how many irons? 9 irons, no? So it will become, for 9 irons it will be into 9. That means 3 1 ja 3 3 ja. So it will be 24 electrons gain.
24, sir.
Okay na? So and here obviously loss will also be 24 electrons.
Wonderful.
Understood how I calculated? Because for one atom it will be 8/3. There are total 9 iron atoms are there. No, see here. 3 3 is 9, no? So total 9 molecules are lost by 8 electrons. Sorry, 24 electrons. See. Next one, what we can say? Non-metal displacement reactions. Non-metal now here what we can say, one non-metal is displaced by other non-metals like this. For example, Cl2 from reacting with KBr, so we will get Br2 plus 2KCl. Now see here oxidation state, what we can say? 0 plus 1 minus 1, 0 plus 1 minus 1, 0 to minus 1, it is of gain, and BR to
So we
BR
lost.
is loss. Now see here, now what we can say, BR is, what we can say, Nana? Replace it, no?
Yes,
And remember here, generally, first we can say fluorine, chlorine, bromine, iodine. Here the point is higher halogens can be replaced by uh, lower halogens. Okay. See here, this is higher halogen, so that it can be replaced. Now, if I'm taking this, let me take this reaction. Can this reaction possible? Is this reaction is possible or not? Tell me. This reaction is not possible.
So that means bromine cannot displace chlorine, sir.
Ah, this only. That one I had written. See, higher halogen is mean what? This is the order, no? First fluorine is lower by mass, higher in the terms, higher mass in terms of. Okay, na? Similarly, if I'm taking this, you tell me whether this reaction is possible or not. Possible or not? See here, higher is, this is higher halide, right?
They're not possible, sir.
Higher is replaced by lower one, no? See, fluorine can replace, listen to me. Fluorine can replace chlorine, bromine, iodine. Because fluorine is the lowest one, no? Let me write in terms of mass, let me take. You are maybe getting confused, I think. Okay, so this is possible. Okay. Last type of redox reaction is disproportion redox reaction. Disproportion
Sir,
terminal.
can you show the previous slide?
Done, Nana?
Yes, sir.
So disproportion redox reaction, very important reactions and easy to, in which, okay,
Sir, once can you go to
in which,
once, sir, please.
what?
Last page, sir. 1 minute, sir. Yes, sir.
Disproportion in which same atom undergoes oxidation and reduction. Hmm, reduction. See here, in all the redox reactions, we have seen two different atoms. We have seen, isn't it? We have seen two different atoms which are undergoing. Okay. Hello. In which same atom undergoes reduction and oxidation. Let me take one example. Let me take like Cl2 when we react with NaOH. That means cold condition will give NaCl plus NaOCl NaOCl. NaOCl means sodium hypochlorite. This compound name is sodium hypochlorite plus water. Balance this reaction first. Balanced, I think, right?
Yes, sir.
Now identify oxidation state change here.
So Cl2 is 0, sir.
Sir, Cl and sir.
0. So here sodium plus 1, oxygen minus 2, hydrogen plus 1 again.
Plus 1.
Here sodium plus 1, chlorine minus 1.
Minus 1.
And here plus 1, minus 2, plus 1.
Plus 1.
Oxygen minus 2,
Sir,
plus
plus
1.
1.
That means what we can say here,
So
chlorine only
checking 2 times.
getting minus 1, that is gain
So 1
of electron, and chlorine only losing
So
electron.
losing 1 electron.
So that means what we can say, same atom undergoes oxidation and reduction, right? Okay. So when same atom undergoes oxidation and reduction means what we can say, it is a disproportion redox reaction. Let me take a one more example if I'm taking Cl2 plus hot matlab, means concentrated. By reaction, we will get sodium chloride plus sodium chlorate. This compound name is sodium chlorate. Okay, sodium chlorate. Balance this reaction first. Let me balance myself only. Balance should not. Here also, if you are observing oxidation state, here chlorine only it will convert into -1, and here it will convert into +5 as well. So 0 to -1, that is gain, and 0 oxidation state to +5, that is loss. So it is the same atom undergoes reduction and oxidation. No? Hello?
Sir?
Tell me now.
Sir, how can we know that how many electrons that it will lose?
0 to -1 means what? How many electrons? 1 or 2?
1, sir.
That only, no.
No, sir. How to know that how many electrons it will lose? Here it is losing. It is gaining 1 electron, and here it is losing 5 electrons. No, sir.
Okay.
Then how we can know where it can lose or gain electrons?
Just for that one, we need to know oxidation state and we need to calculate oxidation state only. Then only we can find out whether it is losing or gaining.
Okay, sir.
Okay. So this is about the disproportionate redox reactions, Nana. So from here we have completed these types of redox reactions also. Okay. And whatever the schedule we had given, I think that we had able to complete clearly, and along with that certain extra topics also we have done. Okay. And let's see what we can do, right? Bye students then. Have a good day.
Bye,
Thank
sir.
you,
Good
sir.
night.
Bye, sir. Good night, sir.